potential energy average to get the total energy. Then we will minimize the energy with respect to the variational parameter. Here alpha is the variational parameter. Like our previous case, alpha is the variational parameter here. So to calculate kinetic energy average, we have to integrate phi star kinetic energy operator psi t tau and put in the function, the operator, that will give a 2 by pi alpha square cube, because psi star psi, so it will appear as square, 2 by pi alpha square cube minus h cross square by 2m for the kinetic energy operator, minus h cross square by 2m, and the radial part will be there. Integration 0 to infinity 4 pi r square comes from the d tau part. 4 pi comes from the integration of the angular part, 4 pi r square dr, e to the power minus r square by alpha square, and the kinetic energy operator d2 dr2 plus 2 by r ddr. There will be another psi here, e to the power minus r square by alpha square. You can do the integration here also step by step, lengthy but simple. So do it yourself, and ultimately you get a value of 3h cross square by 2m alpha square. Similarly, one can calculate the potential energy average also. So similarly, psi star potential energy operator, psi star potential energy operator psi d tau. So it will be like 2 by pi alpha square to the power 3, 0 to infinity 4 pi r square dr e to the power minus psi star and psi will make psi square 2 r square by alpha square 1 by r from the potential energy expression. So this will be the integration value, integration parts rather, and one can get a value of minus t square by alpha 2 root 2 by root pi. It is a very simple integration. So we got both the average of potential energy and the kinetic energy. Now we will get the total energy value. So E will appear as total energy E will appear as 3h square by 2m alpha square minus square by alpha 2 root 2 by root pi. Here also energy contains the alpha term, that means the variational parameter term. So now one can minimize the energy value with respect to the variational parameter to get the value of alpha for which energy value is minimum. So our next task is to minimize energy with respect to alpha. So putting the condition d by d alpha is equal to 0, one can get a value of alpha. You have to just derivative the energy expression with respect to alpha. Putting that equal to 0, you will get a value of alpha like 3 root pi h cross square by 2 root 2 m t square. And now if you put the value of alpha in the expression of the energy, then you will get the variational energy VAR will like minus 4 by 3 pi m e to the power 4 h cross square, and this value is equal to almost 0.85 of the exact ground state energy of hydrogen atom. This is the exact ground state energy E0 value of hydrogen atom. But if we take a trial function like what we have taken, we get energy value 0.85 of the exact energy. Not bad at all, because the function we have taken as a trial function is not an exact ground state function for hydrogen atom. It's basically, it was a Gaussian type function, but even that we get a variational energy that is very much close to the exact energy. So this is the power of variational method. By using proper trial function, we can go very near to the exact energy of a system. Here, for simplicity, we have applied variational method to hydrogen atom only. In our next lecture, we will proceed to the helium atom to solve it by using variational procedure and gets its ground state energy. Before conclusion, I will give you an exercise based on the variational method. You try yourself. If you face any problem, you just contact me. But before all, you have to try by yourself. This is an exercise for the student. We already learned about the harmonic oscillator system, and we know harmonic oscillator potential energy. This is the potential energy of harmonic oscillator, and we know that this potential energy V is half k x square. So potential energy is symmetric with respect to the origin. Now, if we want to apply variational method using a proper trial function for harmonic oscillator system, then you can get a variational energy value. Take phi is equal to cos lambda x as a trial function for the harmonic oscillator system. For harmonic oscillator system, because this cos lambda x is also a symmetric function with respect to x is equal to 0. Cos lambda x will look like this is cos lambda x. This is minus pi by 2 less than lambda x less than lambda by 2. Less than equal to split. Right. Now you have the Hamiltonian for harmonic oscillator system minus h cross square by 2m d2 dx2 plus half kx square. So using this Hamiltonian and using the trial function cos lambda x, or lambda is the variational parameter, you have to calculate the minimum energy value. Calculate E minimum. That's all for today.